morning, cadets, and welcome to the 2023 Jclc Awards Ceremony. As you know, I'm your Battalion Personnel Officer, and I'm pleased to say that battalion staff and I are extremely grateful to work with all of you this past week. We have had more than 130 cadets participate in this year's summer camp and experience STEM design challenges, special tours, competitions, and camaraderie and high morale amongst everyone. You have all made this a great Jclc for all personnel, and we've had an awesome first event for our staff to have run. Now let's begin the ceremony. I will start off by handing it to the Battalion Executive Officer.
First, we would like to thank the company cadres that have been both selfless and gracious as they helped us with our operations. Without them, we would not have been able to run Jclc as smoothly as we did. So thank you to every adult who helped us operate this week, and also a very special thanks to our medical and STEM helpers, James Duke, Selena Quiros, and Spencer Sutton. Throughout Jclc, all companies have participated in a series of events that build their leadership and communication with different STEM activities. Now we will have our company commanders and first sergeants to brief their assigned event, starting with Alpha.
Okay, so I would like to welcome you guys to Alpha Company's trip to General Atomics on the second day of Jclc. So to start it off, we had a lot of bonding time because we had a giant bus delay, as I'm sure many of you guys can remember. It gave us a lot of time to brainstorm a lot of the chants that we started to use for our morning formations and just throughout the day. It also gave us a lot of time to learn a lot about our cadets because a lot of us had never met before. We're all from different schools, and maybe only have 3 people from a school per company. And it also gave us a little bit of time to start preparing for Best Drill Cadet. We had a quick game of tap out that had us identify some individuals that we wanted to submit. Now, onto the actual trip to General Atomics. Inside, we learned about some of the manufacturing processes and tools that General Atomics use. And they have all sorts of different stations. They go from turning a block of aluminum into an entire drone. We got to see some of the CNC machines that would actually cut out the parts in front of us. Some of the 3D printers that would just pull it up out of resin. They had wire stations, prefab, and it was super interesting to see the entire process that goes into making one of those drones. And outside, once we had all that kind of more abstract STEM knowledge applied, we were able to go outside and start experimenting with it by ourselves. We had some electromagnets that we were able to flick around, and you could hold these little magnets that would buzz inside of your hands when you press down the button. We had some microwaves that would blow up the CDs, and the cadet favorite was the electricity demonstrations and getting to shock each other.
Brandon Washington Stumson says he served 5 years as an aircraft mechanic after left the military to pursue a job with General Atomics to design drones. He was later offered a higher position and educated as an electronic engineer. He attended night school and finally graduated as an engineer. While employed as an engineer, he was helping design drones. He was later offered a higher position as project manager with a master's degree in engineering management. Brandon Washington is a shining example of what a passion for STEM can do for you. Hard work, education, and determination must allow him to live his dream.
And lastly, for our conclusion, this trip was a really great initial connection to STEM. It gave us some great hands-on experiences with seeing both what the job field can be like within our own communities, and it also had us have some fun by shock each other and playing with magnets. And I hope that all of our kids have a ton of fun. I'm sure they'll have fun being shocked. Thank you.
Thank you, Alpha. Next up is Bravo Cup.
everyone. I am this year's Bravo Company's CEO, Tyson Kyla.
Hi, I'm Alex Agnew. I am squad leader of Bravo Company.
Hi, my name is Vera Powers. I am the first sergeant.
For the first day of the engineering challenge, we were given instructions to build a robot that could traverse different terrains and complete different obstacles, such as putting balls in a certain area of the playing field and sometimes even pick up cups and stacking them. The mission was just to create a robot that was controlled by one of the cadets. However, we did come across many failures. One of those was quite surprising. It was that we failed to stay awake during the class. So what we did was we had one of our first sergeants say, "Stay alert. Stay alive. Stay alert. Stay alive." And that's what kept the whole class awake.
I'd also like to reiterate that Engineering Challenge 1 was all about building the drivetrain or chassis, which is the base of the robot, that help us start from there and from up into Engineering Challenge 2. Okay, so just in general, memorable moments over Bravo's time in Jclc, which is the Joey's and Chance Makeup. We have bonding time together, being able to create that. Nap time was very important for Bravo Company in the bus. There has been numerous photos taken of me, myself, and my company, along with others. Especially, and the only thing that did keep us awake was the very, very horrible jokes made by our first sergeant Mikado. You know, they were a lot of dad jokes, okay? And we listened to them, but I will not promise I will laugh. Just general things. We have a lot of nicknames for a lot of different people, so even our CO over here got one. And of course, you know, her last name is Jackson. So we've had to just sing Miss Jackson in the bus about every single ride. Because there is no better way to really get to know your CO better. Prime example right here. We did play tap out, just getting ready for breast till cadet, making sure we knew who was the best and we know who was in there. And then just, we have some funny photos over here, especially of mine about to be SAO working on sunscreen. Let's just take a moment to recognize that. Moving on nicknames, I would like to give a special shout out to Mr. Brandon Hastings, Ms. Tinkerbell Bell, and I believe Mr. Territorial over the drivetrain and all the pieces that we have to use to build the robot. He always wanted to do it, so because no one could touch territory. These are some pictures that were taken that we posted up. The big photo with us behind the helicopter is us when we visited the naval facility. Took a picture with our pilot, which is our guide. Picture on your right. Top right will be the picture that I took when we drove over on the boat for Coast Guard, U.S. Coast Guard. We went under the Coronado Bridge. The picture on the top left is also a picture that is Sergeant Major driving the boat. Picture on the bottom right is when we got there, we set up the formation. The picture in the middle with the exit sign, that is a picture I took of our first sergeant and a couple of our cadets being stuck because they didn't want to use their card. So I didn't want to open the door for them, and I just took the picture. The picture with the golf cart is actually a picture of Colonel Swan in the golf cart we see him driving. And we took the picture. We were like, oh, he's driving, we're walking. The picture on the bottom left is when we also visited General Atomics with Alpha Company. That is when we were experimenting with the electricity bolts and shocking each other. We've done with that. And the last picture is just us walking back to our dorms after having a long day. So, in conclusion, for our engineering challenge, we learned STEM terminology was this chassis, the base frame of silicon valence. Scrub is when you are turning your robot, but it is not moving, it is making like a skidding noise, it's not going to actually make a turn. We learned some more terminology, I believe it's called backwards, which is what you use to plug in That's what gets your robot power. That's what allows it to communicate with each other, passing data and power. Most of what we learned was teamwork. I would say for myself as well, as a CO and from learning how to build the robots, there's a lot of failures that came through, and that is totally okay because it helped communication. It helped learning that we needed to read the instructions, we need to change what we were doing and work together. Other than that, we had a really good JCLC, and we're very grateful for this opportunity.
Bravo. We will now have Charlie come up.
Good morning, everyone. I am Charlie Seagull, and this is
I am the Lieutenant. I'm Charlie Sexo.
Cadet First Sergeant Sosa.
Use your outside voice.
So our presentation is about NAVFAC, also known as CB, and their headquarters is located in Washington. But luckily this week we were able to visit one of their facilities down in North Island. And we just had a lot of opportunities to learn about their jobs and their skills. So one of the stations that we were able to visit was CB divers. And what CB divers do in the military, or excuse me, in the Navy, is they do a lot of underwater construction. An interesting fact about CB divers is they only have a limited amount of work hours they're able to do a year, which is 2,000 hours a year, because underwater there will be pumping nitrogen, which long term, if exposed for too long, it will become toxic to the body. It was also interesting that they also do seafloor mapping. It's amazing how we can just map out seafloors just using sonar, and also their headgear, which you can see in the photos. It's the yellow helmet. That helmet weighs 35 pounds, and it's $15,000 for one helmet, which is crazy. But I could buy a car with that, like down here. But yeah, I seen in the photo, one of our cadets was trying out on the helmet, and he said himself that it was quite heavy, even with the assistance of the diver holding it up. But I'll be followed up with my first sergeant on the next slide.
This was our woodworking and construction station that we were able to take over at NAVFAC. On the bottom left, we have a picture of our two speakers, woodworkers, who talk to us about the workways of making stairs. Interesting 7-Eleven rule for stairs, National recommends, which is that rise should not exceed more than 7 inches, and its run more than 11 inches, it will about 17 or 18 inches per step. He also talked to us about how construction in the Navy, and as CVs more specifically, could also transfer out to civilian contracts and civilian jobs. On the bottom right is our other speaker, who was a tribal, I believe, construction worker, and how his experience in the Navy, how he helped out housing basically for like missions on abroad and foreign countries. CVs and stories. So this was one of our last stations that we were able to go to. You can see on our bottom right and top right are
as you guys can see, I'm sure all the cat grade here know that, but the CB is all branches' best friend. So the reason for this is they have employment almost every year, and when they go travel around the world, they build things. The best thing about our job is we get to build things around the world, just make everything become better. So yeah. So that pretty much for our trip out to APAC. We would like to thank you to our talent staff, our cadre, instructor, the Baron, and cadet are here and make this
Charlie will now have Echo Company.
Good morning, we are Echo Company, and our brief will be on the Engineering Design Challenge number 2. I am the Echo CEO, Rosalia Becerra, and my first name.
For cadet for Sergeant Jack Hankins, we also cover EXO, Kensington, Ismail, and Soho. Fortunately, it'll be us two presenting our briefing today. So continuing on, we also have company leadership with our 3 squad leaders. They were all very assertive. We took note on the cadets, make sure we all have our meal cards, and make sure we all have our ID cards, and trips. This also was in 2020, the company guide on to make sure that he was having fun information wherever we went. Some company values that were expressed through our program today with the second engineering challenge would be to foster spirit and to really engage in STEM learning and express unique fields of learning that many cadets may not have done in a regular school time.
So this is a very vital STEM tool that we learn while in the classroom, the engineering design process. The engineering design process is basically a step-by-step guide to designing successful solutions to problems. This is what we use throughout the classroom, throughout our lesson, to make sure that our robots, which we build, would be very efficient. They would be including everybody, and the circle that you see in the middle where it says design and build, test, improve, and redesign is the one that we spent more time on as we continuously tested it and made changes to the design to make sure that it was more efficient and was able to complete all the tasks that we asked for.
Yes, just like CEO just stated, this is a graphic kind of representing how the cycle kind of goes. Imagine it like keep running gear, it goes round and round for each project that you do. In terms of identify, analyze, and at the very bottom there you see the iterate. That little loop, that's very prominent because of all STEM careers and all STEM fields, the iteration and the failure of learning is the most prevalent item that you can possibly do.
Really quickly, before our mission, we were told about how prominent this type of technology, this type of remote control technology is being used in our society today, and how important it is that young people have a good understanding of how it works. So we were told about how robots could, as said on the screen, how they could handle the hazardous or the very dangerous tasks that us humans could otherwise not do. And how they have different purposes and how us, we have to understand how they work in order to make them do exactly what we want them to do, so as we were going to do ourselves.
Yes, now on to the actual mission guidelines. So the mission was to, of course, create a remotely controlled robot that could stack, collect, and I believe gather materials in a specific area. This was done through multiple fields that we get onto in the build phase. This was iterated to us and the research and brainstorming phase, where we would talk with our teammates, discuss, use intercommunication and teamwork methods to really understand, okay, we need these many materials and we need to get this specific item for this specific task.
As for Sergeant said, the 3 design criteria were gather, collect, and stack. For our gathering, we use mostly as you can see in the pictures, these are cadets building the claw and screw onto their robots, which we use to achieve these 3 criteria. The screw would most likely be used to gather these balls into a hula hoop that was on the ground in the testing area. The claw was used to put the balls inside of a bucket and also to stack red cups on top of each other. By being able to achieve these 3 tasks, we would know that we were successful. And during this part of the process, cadets were really able to express their creativity as several of our robots were very different. We had very different designs, and it all really depends on their different ideas. That's why our different input is very important, so that we could share ideas with our group, and that is something that really exercises throughout the
Now, the second part, or third phase of the course, are testing. We want to test a few things. These are multiple constraints, which is it has to be controlled remotely. Of course, we built the robot brain in there, the electronically controlled. Our objective, does it meet the objective that was previously stated? And of course, the robot design. Does it actually work? Is every part put together? Do the gears actually connect? Are there any screws loose? Etc. Continuing on.
With troubleshooting, this is basically the part where I said we had to test and redesign and just rebuild parts of our robots. Every team had their own issues or their own challenges. Either a part didn't work properly, it wasn't doing what they wanted it to do, or they just found a better way of doing things. This is the part of the process that took most of the time. As clearly stated, as clearly shown in the pictures, these are very focused on the different areas of the robots.
Now, this has icons because it also goes hand in hand with troubleshooting things. Troubleshoot, you identify which might be going wrong, and then, of course, as you say, you rebuild and redesign. This is very prominent because sometimes we go onto the field, test our item, and find out, oh, that's an exact material. Oh, got on this objective. This is why we come back, we design our robot, we prove it to become better. The failure will lead to success because you constantly iterate, gather data, and make conclusions as a team.
This is the last part of our whole project. Basically, it's just kind of checking in with the staff that were helping us with the robots and that were our guides throughout the whole process. Here, with the pictures, we're just testing out like how much can the bottle lift? How much can we lift? We learned about the different types of relationships that come with the length of the pod and like the gears used. All of this science was taught to the cadets first, and they applied it through their robots and showed us their use.
The end results of the interview with the cadets, such as on the screen, we asked them three main things: what they liked, what they disliked, and what they learned. Now, on screen, we have some direct quotes from cadet reflections, and then we also asked their companies, is there anything else that you guys learned about? We also mainly learned about different items to like, such as we like to know kind of the building part, the engineering of the actual robot. That was by far the main bottom line of everybody really enjoyed the hands-on work, which was now, as the hands-on work is really important. This goes with teamwork to ensure that all cadets learn their STEM and really explore new fields of learning. That concludes the presentation.
Thank you, Echo. Next up is golf.
Hello everybody, my name is Camila Macedo. I was this year's golf company commander.
And how is this golf company first sergeant?
Okay, so on our first slide here we have the logos from the schools our whole company is from. We have a different variety. As you can see, Crawford, Lincoln, Morris, Mount Miguel, Kearney, Hoover, and San Diego High School. Our first slide here, we have our company leadership, including myself, our first sergeant, our XO, our first squad leader, second squad leader, third squad leader, and our company guide on.
This is the roster for our golf company and our honorary golf member in the Brigade J1.
Golf Company's purpose was to motivate, inspire, and teach overall leadership. One of the world's biggest investment in today's day are developing our youth to become leaders. In Golf Company, this purpose was prioritized through the practice of leadership throughout the company, working together with one another as motivated and inspire one another throughout the past 6 days we spent here together as one company.
There are some photos of some activities we had done in the Coast Guard.
Our visit to the Coast Guard, here were some of our objectives. Tour the Coast Guard base overall, exploring what the Coast Guard does on a day-to-day basis while working, teamwork-based collaborations, and exploring different ways engineering is used throughout the Coast Guard.
And some other photos of activities we did at the Coast Guard, including the rock through the pipe activity.
The Coast Guard included 3 activities all of our company did. The first activity was by far one of our cadets' favorite, which was the Coast Guard speedboats. Throughout this activity, our cadets rode on one of the Coast Guard speedboats, which are used to travel quickly from one place to another on water. Cadets also learned the basic controls of these speedboats and were allowed to test drive it with supervision under the Coast Guard.
Another activity we did was the boat and leakage activity, where our cadets went through a simulation and we had to cover up any cracks in pipes that were leaking water.
Our last activity that our cadets did for the day was learning what Coast Guard, was learning what the gear that the Coast Guard uses to traveling to one boat to another if they're already on water, which was like a ladder, but it could only fit 1 foot. And finally, we got to meet some of their working canines, which were trained to sniff out explosives, and some of our cadets were allowed to pet them since they were not on duty at the current moment.
Cadets learned throughout this trip about the importance of engineering and how their jobs impact different workforces such as the Coast Guard.
Cadets lastly learned from one another the importance of working together with one another, which improved their overall leadership skills and teamwork skills. This is our photo after a long day at Coast Guard. This was Golf Company for 2023.
Thank you, Golf. Last but not least, we have Mine Company.
Good morning, battalion, good morning, cadre, and good morning, guests. I am the company commander for my company, and this is...
I am the first sergeant.
So today we will be talking about challenge 3 for robotics.
The mission statement of Challenge 3 was to design and create a prototype robot that could be submitted along with a proposal to the Department of Defense for a contract. In the photo on the right, this is one of our company's prototypes compared to a government-issued one.
The challenge we had to overcome were, at first, were miscommunication, stubbornness, disharmony, possessiveness, awkwardness, and the lack of motivation because it lasted for so long and kind of boring. But as we went along, we met, we came as a family, we came as a unit, and we got along and were able to overcome these challenges. By having teamwork and by using one thing that was used a lot was a quote, failure as a tool. The key words that were used throughout Challenge 3 were gear ratios, scrub wheels, turning point, zero radius turn, and drive wheel. Gear ratios means which, depending on what gear ratio you want, if you have a smaller gear to a bigger gear, you want more speed, as it was. You want more torque, more force, more power, and if you have a bigger gear to a smaller gear, you want more speed. And scrub wheels means this friction against rubbing against the floor. Turning point means the turning to right or left while moving forward or backwards. A zero radius turn is movement to the left or right without moving in any direction, forward or backwards. And a drive wheel is the distance between